Okay. Hello, everyone. Thanks for coming. Thanks for coming. Yeah, like Jared said, I've actually been coming to these meetups since like 2015 or so. Jared's been trying to get me to talk at one for a while. I spoke at the conferences are less overwhelming because it's like there are so many speakers, so you're less hyper visible. So I've delayed this for about as long as I could. And now I'm here. So today I'm talking about time series analysis with a focus on anomaly detection and forecasting. So just two different ways that we can approach time series. So a little bit about me. I am a proud New Yorker. I grew up here. I'm currently at Codecademy. I'm the head of data science there. And before that, I was mostly at large non-tech companies, JetBlue and New York sports clubs. Before I decided to pivot to modern tech stacks. Got tired of the 90% data cleaning. So yeah, here's my Twitter handle and some hashtags if you want to follow along. I'm also a member of Our Ladies, which, if you're not aware, is another really great meetup in New York for women in data science, but not limited to just women. Yeah, so there's a lot to go over today. So by the end of this talk, we're going to start by learning how to assess the quality of your time series data, just to kind of figure out what you can and can't do with it. And then I feel like I often spend like 60% of my time just being kind of like paralyzed by my data before I actually touch it. Yeah, so forecasting seasonal trends, managing holidays and special events in your forecasts, both of those with Facebook Profit, which is a really cool package that I'll be demoing today. We'll be working with Google Trends data, which I think is always really fun to work with. And then we'll be wrapping up with talking about Anomalize, which is another great package for anomaly detection that draws on Twitter's anomaly detection package and the forecast package. So yeah, so part one, the origin story. So how I got roped into this, Jared sent me a message and was like, hey, you should do a talk on time series forecasting. And this was back a couple months ago for the DCR conference. And before this, I worked at JetBlue. Plane data is really interesting. Jared knew that I worked on some forecasting. He was like, you should share all that stuff. And I was just like, lol, forecasting is complicated, and I have a complicated relationship with forecasting. Also, that's just a small shout out to Facebook for developing Profit. But why is it complicated? I think it's less so like the methods. Achieving the methods are one thing, but I think the complexity is more around like the quality of data that you have and sort of like the unreasonable expectations that people have for forecasting, given the lack of quality data. So my alternative title for this talk is Forecasting with Time Series, or What to Do When Your Company Confuses Data Science with Fortune Telling. I think people kind of think of data science as like magic, and it's like, we're going to give you some numbers and you just tell me what the future holds. And one of my favorite stories about this is I spoke at a middle school career day a few years ago about my job as a data scientist. These really eager sixth graders just hopped on that and started peppering me with questions. This was back in like 2016. So they were like, will Donald Trump become president? This was in January. Will the Warriors make playoffs? And like, basically they can't, their understanding of my job is like, I use data to tell the future. And I think that's kind of true for work sometimes too. Like sometimes work can feel a little bit like this, where people come in with numbers and they're like, well, I have this data, and if I extrapolate it out, you see a lot of like linear regression where it's like endless growth. We will keep 10xing things every year nonstop. And XKCD comic. And I think a lot of it stems from a mismatch in like the expectation of like when you become a data scientist and the reality of the data you get to work with. So I think a lot of people I've heard, a lot of us spend like 80% of our time cleaning the data before we are actually able to work on the analysis. And I think a lot of limitations come from the quality of data we have too, of just like we would like to work with data that's like clean and well organized, with like clear patterns that you can actually like do something that's useful with. In reality, there's a lot of inconsistency and unpredictability in the data. The data is massive. This makes it really hard to track like just one singular metric. And I kind of feel like a lot of the time I'm just like putting out fires and just trying to figure out what's wrong with the data instead of actually analyzing it. So given all of these constraints, I just want to talk through like what does forecastable data look like? Like what quality should we look for in our time series data in order to be like, okay, I think I have enough data that's good enough so that I can create a forecast that's actually useful. So I think seasonal trends, holidays, and known events. This comes in place a lot for a lot of like e-commerce, flights. That was like a major thing working at JetBlue, controlling for holiday travel. I pulled florist or Google search volume for florist since 2010. And you can see that it's very much correlated with Valentine's Day, which I kind of knew tried to be seasonal. And I actually didn't realize that Mother's Day, a lot of people have mothers more so than, yeah, so I think a lot of our job at JetBlue was inputting holidays like Christmas, the surrounding days, like if we knew Christmas fell closer to a weekend, people are more likely to take like long weekends, stuff like that, just sort of the dealing with, you can forecast things when you actually know what's going on. So it's the domain knowledge and known recurring events. And I think the other thing is historical data. You want a good amount of data with recurring regular trends. If you've only cycled through that trend one time, you can't really predict it, or it's harder to predict it. So here is earnings. Google search volume for earnings peaks about 4 times a year every quarter. Companies release their earnings. People want to know what's going on with their stocks. I figured there were a lot of finance people in here. So when shouldn't we forecast our time series data? So I tried to think of like interesting case studies. Tesla could be a lot of companies, you see that quarterly peak. Tesla is interesting because Elon Musk is pretty erratic and kind of makes it conflates or interrupts like product launches and quarterly whatever earning calls by just tweeting random things. So it makes it really hard to predict. And speaking of unpredictability, Donald Trump recently, or just for the past few years, has been really erratic, and his tweets or behavior is pretty hard to predict. This is really hard to forecast. I guess the only known is unpredictability. Or, spending on something more positive, if you only started collecting data recently, or a recent change of events led to something different, like a product launch or a rising star in politics, you don't really have enough data to forecast. It's really hard to know where this is gonna go. And I think, speaking of Alexandria Ocasio-Cortez, it's basically leads me to say growth is a double-edged sword. So growth is great, working for a company, being able to get paid, being profitable. That hockey stick growth that all these startup companies and VCs want you to achieve. It's great from a business perspective. From a data science and forecasting perspective, it's really hard to figure out what the future will hold when you're launching multiple features over the course of a year. And basically, growth just creates uncertainty in time series forecasting. And when you have a forecast with a range that looks like this, it's not really useful. Like, it's not actionable. I think like most executives, if I gave this to them and was kind of like, there is a 50% range in how you will perform next year, we'll be like, okay, you're fired. But yeah, so I'm going to start talking about profits. That what's the last chart? And I'm not live coding. Live coding always goes terribly, so I'm gonna pretend to live code. This will be a live code simulation. So what is Profit? So Profit is a forecasting package that was open sourced by Facebook. And it's really great. It draws from a lot of really popular packages, like Forecast was the big one before that. How many people in this room have used Profit? Okay, not that many. How many people have used Forecast? A lot more. So the way I describe Forecast, and I think the way that Sean Taylor, the creator, has described it too, it's basically like Forecast, but you remove a lot of knobs to make it a little bit easier to use. So Forecast can be really confusing for a lot of beginners, and even for someone who's been doing forecasting for a long time. It has a lot of complexity that isn't always needed. And Profit kind of removes a lot of the noise and just focuses directly on mostly time series analysis, and specifically for business forecasting. So Facebook is one of those companies that just has like billions of events firing every day. So they have a lot of data, and they try to use forecasting to solve these problems and to predict what's going to happen, new features, stuff like that. So Profit does really well with business metrics, and that's kind of like the key audience for it. So it does really well with seasonal data, where you have like hourly data or weekly data captured with at least a few months of history. So kind of what I was saying before, if you have a good amount of historical data. And seasonality, it does really well with, they call it human scale seasonalities, so day of week and time of year, and important holidays. So they mentioned the Super Bowl. I think Sean Taylor is like really into football, so he put that in there. But that was like a thing that we had to do at JetBlue too, actually. Like every time they announced a Super Bowl location, someone had to go and close up all the flights to prevent them from selling out immediately. So yeah, like controlling for random holidays that are lesser known are a big part of time series analysis. And knowing the holidays that are unique to your business are the things that are kind of fall in the domain knowledge part of data science. And where Profit does well too is it does well with data where there's missing values. It kind of, I'll go into it later, but it does well at smoothing over missing data and still projecting out seasonality, because it assumes seasonality is like a strong function of your trend. So how does Profit work? I promise this is like the only math here. It's not, it looks more scary than it actually is. So Profit, I think when we think of forecasting, a lot of people are used to people working with like massive sprawling Excel spreadsheets with like multiple tabs and like multiple department heads putting in their own version of what they want to happen. And it's really complex. Or you have Forecast, which is also a pretty complex, I would say. It requires a good level of knowledge to work with. Profit reduces a lot of this, and the only input is time. So you're just working with time series data. That's it. Your only input is time. So you're putting in time and your observation, and you're measuring that. And Profit does really well with working with seasonality, like I mentioned. And the model basically assumes that there is a general growth trend. So is it trending upwards or downwards overall over the years? Seasonality, so whether it's weekly, monthly, hourly, and holidays. And this is a user input that's we talked about before with like Super Bowl, calendar, holidays, or so on. So I mentioned I like to work with Google Trends data. So to start for this part and for anomaly detection, we're mostly working with Google Trends data. Google Trends R is a really good package to play with. I think it's just really fun to look at like spikes and what people are searching for. So once you have your data frame, Profit makes it pretty easy. You kind of have to do some prep work, but it's not a lot of prep work. So you need a date. So Profit, one of my nitpicks of like Profit is it forces you to name your columns DS and Y, DS being your date and Y being your observation. So this is just prepping the data, cleaning it for analysis. And then Google Trends data. So are people familiar with how Google Trends works? So it kind of normalizes search volume over time. So it's a minimum of 0 and a maximum of 100. So knowing that and doing a logistic regression, I specify the floor as 0 and the cap as 100. This might vary for flights, for example, when we're on JetBlue, every flight had a maximum number of seats, so there are only so many seats you can sell. And then you make your data frame for the future. Again, you specify the cap and the floor, and you create your forecast. And this is, I generally don't look at it, but the output is kind of like easily exportable into like a spreadsheet. It's a data frame. Everything is, you have a midpoint and I did not rename these correctly. But you have a midpoint and lower and upper ranges. And when you plot your forecast, it looks something like this. So this goes back to the Google search volume for earnings. So it's able to predict the quarterly spikes in people looking for earnings calls or information about company earnings. And you can actually break out the components of your forecast and look at the trend over time. So that top graph over there shows us that Google search volume for earnings has been trending up since 2016, and it shows you the 4 spikes a year. So if you look at the forecast for the forecast output, it's able to predict the increase in Google search volume starting around the end of April when most companies close up their Q1 earnings. And this is, I call it simple, but now that I'm going over it, I'm like, profit is complicated. But or it's hard to go over in an hour. There's a lot of documentation online though. I encourage you to go look at it. But this is where the human input comes into play of inputting relevant holidays. And examples of this would be not just like bank holidays, but company earnings calls, product releases, all the known information that you have about the data that you're analyzing. And that's the data science Venn diagram that inevitably pops up. But this is where the substantive expertise comes into play of just knowing about what you're analyzing and the subject matter. So best practices for forecasting, set clear expectations. I think I had to learn how to do this, but this is basically just like being realistic and honest about the data that you have and what level of certainty you can provide. So if you just launched a new product, or let's say someone comes to you and is like, can you forecast this? I just launched a product 6 months ago. Feel free to be realistic and be like, no. Yeah, I think just setting clear expectations is important. It takes a while for people to learn what can and can't be forecasted. I think the second point, sharing upper and lower ranges also allows people to be more realistic about what they can expect. When you share just the midpoint, and I think this has still, I'm still trying to figure out how to coach people who work with forecast numbers to do this. Don't just use the midpoint, use the upper and lower ranges. If you have a really wide range in your data, that tells you that your forecast might be brittle and not hold up. Updating your priors, so I talked about specifying the capacity and floor. That might change as your business changes, so make sure you go back and change those. I like to do it at least, it depends on the type of forecast, but I try to look back on forecasts like about quarterly for our like new signups forecast, for example. Holidays and launches. There are certain, so Profit does well with, like it knows when you're projecting something out monthly, it'll know that Thanksgiving, for example, falls towards the end of November, but it won't know that it changes every day. So if you want it to be more specific and accurate within the week, you go back and update your holidays. Same with product launches when you're actually doing this in production. And I'm going to skip ahead to the last point, but use your spreadsheet people. So I think a lot of data scientists will, especially like out of school, come in really optimistic about the math and kind of discount the internal knowledge that a lot of people have at the company. And this knowledge is really valuable. Like, I've learned so much from people who've been at companies for like 10, 20 years who maybe aren't data scientists and aren't very numbers oriented, but just know a lot about the product and the business. And this has been like really critical for developing useful forecasts. And going back up, I think I'm still trying to figure out how to work profit fully into our business. I think something where it's come in handy is I realize those sprawling spreadsheets won't ever really go away. And where it's come in handy is having people take a forecast and telling them, well, this is the reasonable range you can expect unless anything changes, and having people at the executive level determining, well, if we are able to convert or increase SEO, like how can this change our target? So targets are like wishful thinking. Forecasts are what you can expect to happen given the current constraints. Okay, so going into the last part, anomaly detection. Just as a side note too, I'm like halfway through today, I was like, I went way too ambitious with this talk. This was too many topics. But hopefully you come away with a little bit of everything and go home and explore more, just because there's so much that can't be covered today. But both of these are really cool packages. So for anomaly detection, kept talking to Jared at that time about forecasting, and I was like, hey Jared, I'm really disillusioned about forecasting, but I'm really excited about anomaly detection, because I just had was able to implement that at work and was really excited. And anomaly detection has been really critical, I think, for providing people something useful, so you're not just saying no all the time. I feel like I talk to people, to data scientists on my team a lot about having to say no to people of like, no, sorry, like we can't provide that data, or no, we haven't been collecting that. And it just, you feel like the bad guy a lot of the time. So I think where anomaly detection has been useful is you're able to provide something that's often more actionable than a brittle forecast or something like that. And it's helped reduce the number of fire drills. So fire drills. So going back to anomaly detection, it's really come in handy for reducing all of this. I feel like this probably is true for a lot of people at work, but just a lot of the time something comes up at work and I feel like I'm putting out fires more often than I'm actually doing analysis. So I joke that my typical workflow is I start working on something I'm excited about, and then suddenly someone like runs over to me and is like, oh no, like something is broken, I don't know what, please help me. And the thing that I was working on just kind of like falls away, and I just think longingly to working on something more interesting than putting out fires. So anomaly detection, or how to know when something is terribly wrong, or put out fires ahead of time. So some applications of anomaly detection: fraud detection, monitoring KPIs. I found it really useful. What I did at work was I basically set up anomaly detection for key checkouts, checkout flows on the website. So when something like that breaks, which is what happened here, we're able to detect it earlier instead of letting it go on for longer than necessary. Nature, weather, there are a lot of different applications of anomaly detection. So I'll be talking about Anomalize today, which is a really cool package to help you go from this scary, really sad graph to this, where you can instantly identify and interpret like when something potentially broke or changed. So Anomalize, again, we will be working with Google Trends data. Anomalize plays really well with the tidyverse. So how many people here are familiar with the tidyverse when I say that? Okay, so most of you, but the tidyverse is a concept of programming where you just, to put it simply, it's like cleaner code. It's changed my life. My code is so much cleaner now. It looks almost like a real programming language. And it's really easy also for non-programmers to read, which I love. And Anomalize is set up in a way that kind of uses this framework of thinking to understand. So your code looks really nice. It plays well with like other packages within the tidyverse. Okay. Nope. Yeah. Oh, yeah, that's it. I forgot. Yeah, Anomalize is really easy to use. There's so little code. So you basically, you install tidyverse and Anomalize. You prepare your data, and then you anomalize. And this looks like a lot of code. But again, please go home and play with it. There's a lot to play around with. And I'll talk more about the methods here in a bit. So Anomalize helps you take your data to this. So if I'm looking at Google search volume for vote, this was really fun to interpret. But I actually did this for the DCR conference back in November, shortly after the midterms. And the midterms actually like outranked a lot of previous presidential elections because people were so excited about making things less depressing. But if you look at the outliers, you have the 2016 presidential election, the 2018 recent midterms, which were a big deal, and then all the other presidential elections and some sort of, and some smaller scale anomalies of probably local elections or surrounding dates. Florida, I feel like proxy keywords are really fun. Florida, the swingiest swing state. So I think just because I was going down the voting trend, it was fun to look at how searches for Florida peak like every presidential election because people are like, what will they do now? And in the recent midterms, in the midterms it was particularly contentious. I feel like all elections there are like within 1%. So there was really high search volume for that. And yeah, similar to profit, there are a lot of like really cool functions within Anomalize that let you look at like the inner workings of anomaly detection. And I think this is nice because when we talk about packages like Anomalize and profit, I think interpretability is really important as a data scientist, providing things that are easy to understand, especially when you work with stakeholders who might not be as technical. People are really scared with what they can't see, and when they can see what's going on, people tend to be more accepting of math. But so this is kind of like a cheat sheet of what I've learned about anomaly detection. So Anomalize actually draws from two different existing packages. Anomaly detection was anomaly detection, one word, was a package that was open sourced by Twitter, which deals with a lot of event data, a lot of outliers, the eccentricities that I showed you with Elon Musk and Donald Trump. And Twitter's open source their anomaly detection algorithm that's really great for dealing with like highly seasonal data, but also teasing out outliers. IQR is better, and standard lowest is better if seasonality isn't a major factor. So kind of if you're looking at shorter term data and you're not looking at long term trends, I usually defer to standard lowest, but it's easy. Anomalize makes it easy to kind of like play around with all the different algorithms to see what works with your data. Oftentimes I go in with like assumptions about what I think will be true, and I end up being proven wrong. And adjust the trend period. So over here, the trend period is a year. address the trend period using domain knowledge. So this is just kind of what it looks like in action. Movers, people look for movers about like every month. People move all the time. Running it on standard Lewis from data since 2015. Once you do it with Twitter, it removes a lot of the anomalies and pulls in your median. And then once you add in GSD, it pulls it in some more. So if you look at the gray range, yeah, it's cool. So try this on different keywords. I had some fun just playing around with this. This was from November. I don't know if it's still fair game to make fun of Pete Davidson, but I'm going to do it anyway. So Pete Davidson, for those of you who don't know, got engaged to Ariana Grande shortly after they met. So I think they met like there, and then people were like, who is this guy? And then a couple weeks later, they got engaged. The internet went crazy. The thing that I find interesting too is you can see the like how cyclical tabloids are of like this trend here, but there are outliers that break away from that trend, like shortly after when they called off their engagement, and search volume went up again. So try this at home. I just kind of try to think of like things that would be funny to look at, but I pointed out, or Elon Musk is always funny. I don't actually follow him that much, so it's hard for me. I just know he's like kind of erratic. But sports, weather, politicians, Bitcoin, I feel like is also super erratic. Memes, events, anything timely, and anything else you might think of. I feel like at the end of the day, when you're a data scientist, just work with data that's interesting to you. That's probably gonna get you to learn the most. For me, it was Pete Davidson, apparently. So additional resources, I'm gonna put this up over the weekend, and linking to a lot of extensive documentation about these two packages. There's so much I couldn't cover. Both of them are really great. I also linked to the Not So Standard Deviations podcast. Have people listened to that? It's a really funny podcast. It feels like you have like two data science friends in the room with you. So when you're working in silos on your two-person data science team, you feel less lonely. And they have one with Sean Taylor, the creator of Profit, where he kind of talks through Profit and why he developed it and the intended audience and kind of like his learning. So it's a really good episode for just learning about open source development, but also like forecasting and what that looks like at a business. And Codecademy, I've been speaking at conferences for a while now for Codecademy, and every time I have to be like, we don't teach R. But Learn R is finally coming, so that's really exciting. I did not teach it, but there are people. I'm just going to shout her out. But Natalia is a curriculum developer. She's really awesome. And yeah, it's going to be great. And March meetup. So I went through this faster than I thought. So March meetup. Jared mentioned it will be on choosing a deep learning library. I took the liberty of helping the March speaker pull interest in deep learning. It's at like peak hype right now, so if you want to be at dinner parties and like sound like you know what you're talking about, go to this talk. If you've also seen things like that where there's a picture and like some service is able to detect what clothes you're wearing and you're like, why is this service analyzing my photo? You can go find out how that works. In the spirit of full disclosure and also Valentine's Day, Jesse is my statistically significant other. I feel like I have to disclose that, but also geeky Valentine's Day jokes. It's a good meme. So that's it. I finally have time for questions. I feel like I actually gave a talk like this before and had no time for questions, and there was so much content. I felt really bad, like I was just abandoning all these people and just dumping information on them. So if you have questions, feel free to ask me. Oh yeah, I guess as a last note too, just I put a note here about supporting each other. I've been coming to like this meetup for a really long time, and I think just having this community has helped me grow so much as a data scientist. And I probably would have abandoned data science a lot earlier if I didn't have it. So support each other. Good luck, have fun, play around with data like Pete Davidson or whatever is interesting to you. Data science used to seem really scary, and sometimes still is. Like an hour before this talk, I was like, everything's trash, I can't do this. But yeah, I don't know, looking around, I'm just like, I know so many people in here, and that's wild. Like, I came into this room like a few years ago and was like, I have no idea what's going on, I don't know anyone, and now I'm like, I still sometimes don't know what's going on, but that's okay, because I'm eating pizza with my friends. So yeah, just appreciate this community, take advantage of it. There's so much that Jared does to support the data science community in New York. So yeah, with that, questions? I'll
We don't have microphones, so I'm going to ask you to shout your question, and I want you to repeat it so for the people on camera.
It's like a community forum. Sure.
You were talking about mentioned a couple of anomaly detection methods. I think you called one of them Twitter, I guess came from Twitter, and the other one was some abbreviation. I am not familiar with either one of them. Can you provide some definition as to how each method, what kind of anomaly it looks for, and how it looks?
Yeah. So the question was, I talked about, let me try to flip back to it. Flipping through all the memes and, flip past it. I think I also just went way faster than I needed to, because I'm always afraid of running out of time. So sorry if I didn't have more time to spend on this. But basically, on a high level, Anomalize just supports Twitter, and STL stands for Standard Lewis. Am I pronouncing that right?
With the Lewis group?
It is Standard Lewis, right? The self-doubt creeps in. But so the two, Twitter tends to work really well with very seasonal data. Twitter has, if you think about Twitter's business, they just have a lot of seasonality built in, of like people tend to tweet at certain hours of the day, certain holidays, events. So Twitter deals well with seasonality and helps control for it. Standard Lewis is kind of fine for the other 90% of the time. GESD and IQR are, if you go back here, those are the two methods for dealing with what we call the remainder. So once the seasonality is controlled for, you're left with outliers, and you have to choose a method to figure out how to deal with them and determine which one is an outlier and which one isn't. I can't remember the exact math of it off the top of my head. There's a lot of documentation online though, and the two, GESD and IQR, are just different ways of determining whether something is truly an outlier or not. Sure.
My question is about assumptions. So how do you think about, let's say, assumptions, getting the business stakeholders' inputs into the assumptions? Imagine as a scenario in the airline industry, jet fuel prices. How would you think about that?
Yeah, so the package, okay, I keep forgetting. So the question was about assumptions, and how you incorporate assumptions into your model from people who are not directly working on the model, so business stakeholders, leadership. Yeah, I think the thing to bring up, I feel like every time I talk at something, data science, people ask about assumptions, as if data scientists are immune to making assumptions too. So I think that's the way to approach it. It's really hard to incorporate feedback from everyone. But I think when it comes to assumptions with profit, it's less, it comes up mostly with holidays, but I think it's just like, trying to be as collaborative as possible while still getting your job done is kind of my approach. So spending time collecting people's like advice, people who've been at the company and have domain knowledge far longer or far more than I do, and trying to incorporate as much of that as possible into the model, but kind of cutting it after a certain point because it just, you go down a rabbit hole of, I feel like there's also the other thing that I fall like immune to, or the trap of like feeling paralyzed by your assumptions, where it's like, oh no, if I made all these assumptions and my analysis kind of hinges on this one assumption, and once I take it out, everything falls apart. Trying to move past that is kind of hard too. I'm kind of like, I have strong opinions on this. I feel like I could do a whole talk on like data scientists and assumptions, but I think it's just like, the best you can do is just make everything really clear, try to communicate what assumptions you had. If a lot of your model is based on this one assumption about like an increase in fuel, like you mentioned, for airlines, you should make that clear when you communicate out your forecast. Yeah.
I have actually two questions. The first question, how you deal with missing data? Let's say you have a process that creates data, and then the process is broken, there is no data, and finally the process starts working, and you have a bunch of data, right? So now your model will be broken because there is no data, and now there is a spike. So how you would deal with that situation? And the second situation, what do you do if you have multi-seasonality in your data?
If you have multiple
Multi-seasonality, how do you
multiple
deal with
seasonality.
multi-seasonality?
Yeah. Okay, so the question is how to deal with missing data and multiple seasonality.
Yeah, multi-seasonality.
Yeah. So I think when it comes to missing data, that's where the domain knowledge comes into play. It's really hard to apply like a one-size-fits-all solution, but I think it's just like assessing how much damage there is. There's like a wide range in missing data. I've seen like if you have like one day missing, Profit is pretty good at controlling for that. But if there are or Profit is actually pretty good of dealing with seasonality, so I would actually give that a shot if that works for you specifically, because it basically just tries to look for the trend and seasonality over time. Can you elaborate on what you mean by multi-seasonality?
So let's say you are looking at in your like yearly data, right? And you have like days, and there is there can be like, for example, like monthly seasonality. For example, January you have like always like during the week. During winter you have like spikes, and during summer you have like low volume, and plus you have daily data like during holidays you have something, or like weekly seasonality when you have, let's say, on Monday spikes and on Sunday it's like
so this is thing. I see. So this is dealing with different types of seasonality, as in daily, weekly, monthly. Right. I duplicate my forecast a lot, and I will produce it for like a daily forecast, a weekly forecast, a monthly forecast, and allow people to use whatever is useful for them. That kind of, because if you think about it, there's a wider range of I'm forgetting the word, but your upper and lower ranges can be much wider for a monthly forecast versus like a daily forecast. So generally just duplicating the forecast for different periods of time can help with that.
Forecast and peak can help.
Sorry?
The forecast package allows you to put an indicator variable creating multiple seasonalities.
Exactly.
And the peak package does some of what you're doing automatically.
But don't you need to clean up data before like that, because your forecast won't be accurate, I think.
Well, you're always going to degrade something. But
Yeah. Yeah, you don't have to reshape your data. The package makes it so that you can specify it and just easily duplicate your forecast for daily, weekly, monthly, whatever works for you.
I use SQL and Looker scheduling to do a lot of learning, and I want to move towards something like Anomalize, but I don't know what I would use to schedule it or format the results and send to stakeholders. Do you have any suggestions for those?
Yeah. So someone asked a question, they use primarily SQL and Looker, which is a BI tool. And that helps schedule a lot of the analysis. So the question is, how can they schedule something like anomaly detection? R is, yeah, R. So I think R, just learning how to program, you can schedule a lot of those tasks to run. One of the ways that I've been trying to use the forecast is piping it into, if you work with Redshift or whatever data warehouse you have, piping your forecast into the data warehouse so you can pull it into Looker has been really useful. So there are ways, but it does require learning like a little bit of R or Python or your preferred programming language. But you can schedule a lot of the same tasks. You can also do
like with cron, you can schedule like an R file.
So you can, yeah. There are various ways of doing it. It depends, but it's.
Studio Connect.
Yeah, I haven't used that.
It lets you generate R Markdown reports, which you can mail out on a schedule with interactive graphics and.
Yeah.
What's that called?
R Studio Connect.
Oh, the other, yeah, I've actually found just a tip for people too. Have people used Mode? It's like a BI tool. I know there's one Mode user too. Yeah, Mode is like a BI tool that has a free version, and it actually lets you run and schedule Python and R notebooks and connect it directly to your data warehouse. Or there are free and paid versions, and I forget what the pricing looks like. But that's really useful too, because it allows you to kind of set up an environment for analysis without having to talk to like a data engineering about spinning up a cluster every time you want to do something. Any more questions?
Yeah. So when you talk about holidays in the in the first part of the presentation, you said you could put in sort of regular traditional holidays and also sort of anything that's a kind of a one-day event type thing, right? So
yeah.
Like product launches or conferences or something like that. Does it have capability to go back and say, in the past I've had holidays, I've had product launches, I've had conferences. I have another conference coming up next week or next month. Can it update the way it'll predict what will happen based off of the fact that the thing coming up is a conference and not like a bank holiday?
Yeah, so you can specify, so I can talk about this. I was worried I wouldn't have enough time, so I didn't go into this too much. But the way the holidays work is it's a manual input. So here I have an example of like 2 different types of holidays. So holiday post is holidays where the day after the holiday tends to have an impact on your metric. Holiday pre is like, you can see the lower window and upper window. And that can be more than 1 or 2. It can be however many days or weeks, whatever time period, you know. So if the conference goes on for like 2 days or something, you can put +2. And then it binds the different types of holidays together. So I like to separate out the different holidays based on how long of a period or what window of time and in which direction, and then bind them together into holidays here for the analysis.
But if you're, I guess my question is not, you might have like holidays which are both like post, but some of them are like Christmas but some of them are conferences. So Christmas might decrease the amount of traffic you have, but conferences might increase the amount of traffic you have.
Yeah, so you would try to group them together based on likeness.
They are not seasonal, right? They what will happen next year, so you just have to believe them from your data. I mean, you won't be able to predict them. Like holidays, they happen every year, so you like code them here.
Well, that's what I'm wondering, if there's a way to know that there's certain types of events that occur, even if they're not regular.
Yeah, so you would put that, so for example, if it was a product launch, you would just have a product launch data frame and then put the dates for those.
Even with the lower window and upper window, it would be the same as the other ones. It would know it's a different type of thing.
So for each of these, it's specifying the data frame. So if you have a product launch, for example, that would change your trend for like a full week, you would put that in like product launch 1 week or something. Yeah, and then just change the upper window, I guess, to 7.
Okay.
Yes?
That's like an add-on question. out what the effect is supposed to be?
Yep.
Is that what's happening?
Yeah. And then it incorporates, when we talked about the growth trend, it incorporates a trend over time. So let's say 2018 is far stronger than 2017. It'll try to adjust for making Christmas in 2018 stronger than Christmas in 2017, if that makes sense. Yeah. Oh, yeah, also I actually didn't talk, to talk about how well forecast does, there are weeks where it's able to forecast how many signups we get on our website within like 0%, like 0.005%. It's crazy. And it's really simple, so it's really simple once you kind of like cycle through it a few times. So I would encourage you to test it out with whatever metric you work on, because yeah, the first time I used it, I was just like, how can something so simple be so effective? But yeah, Profit does really well with time series data.
I never used Profit. Is it Python compatible?
Is it, sorry?
Python compatible. I mean, you can use like, okay.
Yeah, it's, yeah, I'm not a Python user, so I did this with the lens on R, but Python is Profit is available in Python and R, so pick your poison.
How many, like, what's the parameters you can tune in the model? Like, what's the input parameters of the Profit model? Like, you have some input 3 years of data, you want to predict, I don't know, 2 months of the forecast. You're giving this input plus the time series, right? You have X, you have Y, right? And what's the parameters you are tuning, and how is this done? Is there some cross-validation? What is the cross-validation?
Yeah, so the question is, what are the inputs?
Yes.
So the inputs are, you put in your time for logistic regression. So you can do linear too. It was just for this example with Google Trends data, this was logistic. When you do logistic, you need the cap and the floor. And you specify so this kind of goes back to your question about different periods. You specify the frequency. So here I'm making I'm predicting the future out 52 weeks, so a full year out. And different parameters. I didn't get to touch upon this, but in addition to holidays, you can also put in change points. So if you know, for example, this is where product launches it's useful for product launches or some sort of significant change too, or like the election outcomes or something like that. You can specify the change. So Profit tries to manually detect the change point, so sort of like an inflection point in your data, but you can manually override that and and change it depending on if you think you know better than Profit is able to detect.
On the top level, like how it works under the hood is the Profit. It kind of like decompose the time series in the trend part plus the seasonality, make prediction of the trend, and then reconciles the prediction with the seasonality. Or how?
Can you?
So basically, you have the time series, right?
Yeah.
And how does it work under the hood? Like,
Just
so
the
it
formula,
does decompose
The formula?
Plus the seasonality
Yeah.
part predicts which part he predicts. He predicts the trend.
Yeah.
And then he reconciles the prediction with the seasonality.
Yep.
Right?
Yeah, so the output, there's a lot more in the forecast, so I only pulled just for readability, wait, actually maybe I can show you. So the forecast, the forecast itself, the output has a lot in there. For the purpose of this talk, I only looked at the upper and lower ranges, but you can kind of look through how it interprets the yearly trend, and this kind of lets you look under the hood, if that makes sense. The thing with Profit is it can be simple, but it can also be really complicated. So it depends on how deep you want to go into interpreting your forecast. Yeah. Any other questions? Yes.
Yeah. Do you have a good way to quantify seasonality? Just if you're choosing between like the Twitter algorithm, which is what I've used in the past, but then I haven't used the other one that you mentioned. So trying to decide, which of those should I use, and also could you have that happen automatically if you were using Anomalize and trying to just have it scale to whatever you're choosing the right one.
Okay, I thought you said like time was up. The question is, now I'm forgetting. The question is quantifying seasonality and choosing between whether you should use Twitter, the Twitter method or not. Good question. I don't know how you quantify it exactly. I think it's more like looking for characteristics of your data. Twitter tends to do well with like longer term seasonality. And like for example, the Pete Davidson example, I just used standard Lois instead of Twitter because there's no seasonality in there yet.
But you did that by looking at it.
You use STL for decomposition as well. The package with the anomaly detection, it uses
Yeah.
STL.
Yeah, so Twitter uses STL, but it also has GESD is also part of it. So those are two separate things. Wait, now I'm like, sorry. So the question was.
Other than looking at your data,
Yeah.
is there some way to quantify it so that you could pass that to your function and it would choose the right one?
Like choose the right one for you?
Mm-hmm.
Like, so the question is whether you can kind of like quantify what seasonality is so that the process of selecting the method is automated. Good question. Let me look at so I think there is a way. So I think the good thing about this being done in tidyverse is you could write a function to do it and wrap it within that. I haven't tried it, so I don't want to be like, here's how you would do it, but it is possible.
I mean, if you
Yeah.
the goal is reduce errors, so you can just like combine them to like take like bunch of methods and just like take average and just like I'll do like something. Yeah, usually like bunch of methods they work really well on average.
Great. Yeah, relevant to my current work as of today, so I just was
Yeah.
curious if there's a way to.
Yeah, I mean it makes it, because it's like a tidyverse package or follows that. It makes it really easy to try to do that or to wrap it within a function. So I would suggest trying that.
Cool.
I haven't tried it myself, but now I'm like, I should do it.
Yeah.
Good idea.
Thank you.
Question.
Would you ever use profit, not necessarily to forecast, but to kind of say, oh, I want to look at the seasonality of this and, ignore the overall trends just to do a specific seasonality analysis?
I haven't used it specifically for seasonality analysis. Like, what type of seasonality analysis are you thinking of? The question was whether you would ever use profit just for seasonality analysis.
Right, if you wanted to kind of know, either weekly or season or annual trends.
Yeah.
But you wanted to like separate out the general trends. You just wanted to know what parts of the year are better.
Yeah, it does allow you to do that. The part that I showed with the forecast components. So this, I pulled weekly Google search data, but if you have daily data, it's able to tease out like the day of week trends too, like if Mondays are stronger or Saturdays are weaker.
So you wanted to have like charts and be like, oh, so now I know I should always deploy something on Mondays because Mondays are the best or something like that.
Yeah, I think for like business use cases, it's good for like demand planning, servers, stuff like that. Or when you think about like marketing and the product side of things, like we have used seasonality to help decide when to run like sales or promotions, or if we know back to school season is really big for Codecademy, so we really want to be able to anticipate that and capitalize on it. Yeah. Any more questions?
Let's do two more myths.
Okay, two more max. Second and last.
One question I think got asked
Yeah.
earlier, but lost. Like, how do you do with the steps like using profit, like cross validation? You separate your data. If you have like 5 years of data, you use the first 4 years to train it, and then look at the accuracy on the last year. Or like, what is the standard way of doing that?
Yeah, so I've done that before where I've just pulled, I pulled the data like up, or the full data for the actuals, but trained it using like removing the last few months or last year.
It's a little bit different. You don't do cross validation here because you have already like before your data, right?
Okay, I
It's
guess
a formal, it's
you
a
can do
formal,
cross-validation,
it's a
but-
formal more,
Yeah.
it's more analytical than.
It's more like testing. I think he means like testing your model.
Yeah, so
Yeah.
cross-validation in particular, but what
I
is
think
the,
that
like
there
with
are
all the
also
parameters, like
for
putting the
the-
hyperparameters, what's the right best way to do that?
They use AAC and DAC as a method inside the strategies. They already do this for you. They already give the best model based on your data.
But there are hyperparameters you just specify by hand, right?
Yeah.
But these are only like weekly early discrepancies. But after you specify that, they pick like all the packages. They pick the best models for you based on AC and.
So there is some inbuilt hyperparameter.
Right.
But that's true for any machine learning.
Yeah, but you need to know your data better.
Yeah. I think if you're doing it or for what you can control, I think it's just kind of best practice to know before. Like profit worked really well for us, but it might not work well for your data. So in order to test whether profit is good for you, I would suggest like slicing some of your data and seeing how accurate it is.
Both forecast and our sample have time series cross-validation you can use.
Yeah.
The forecast package has TSCV and Max has written a whole blog post, a whole article about how to use our sample for doing time series cross-validation.
Interesting.
Yeah.
They're both available for you.
Thank you.
Yeah,
or
forecast.
What Catherine's doing, fit on Fourier's putting the fifth is also.
Yeah, forecast is a lot more robust if you want to just have more knobs to play with.
Yeah.
Last question. Yeah, last question.
I think you already
Pressure.
spoke to this a little bit, but yeah. So when you are adding holidays, is there an easy way to make some holidays like more powerful than others? Like for instance, say you're working with education data across the country, and some schools use some holidays and some schools don't.
Yeah. Generally, so because seasonality is such a big component of profit, if it's a holiday that occurs around the same time of year, it won't put one holiday at the same magnitude of all other holidays, if that makes sense.
Yeah.
Does that answer your question?
Sure.
The other way of doing that is also separate it. You can separate it out and use the upper and lower windows again. But it's pretty good at. I think I found that so when working with holidays, I think it does pretty well with like weekly forecasts and monthly forecasts, for example. But daily forecasts, it's not always great just because daily forecasts are it's just hard to forecast daily. And I think that was the last question. But thank you all for coming.